Okay, this is chapter 13, which speaks about mostly about the energy. We did talk about the kind of energy, types of energy we have. Somebody remembers what type of energy we have before? Long time ago, kinetic and potential, correct. Kinetic and potential. That's type of energies. Now, always those energies, what the purpose of the energy is to do what? Work, correct? I don't see the energy, but I can feel its impact. Here's the rock at rest. I have what? Potential energy. Then let the rock go downhill, down the mountain. So the potential energy turns to kinetic energy. I don't see both. I cannot see both. But then the rock will come on my foot. I feel the pain. It hits my foot. That's the work. It's done on my foot. The pain I feel, that's the work of this potential energy being converted into kinetic. Kinetic converted into what? Into work. So that's all about the conversion of the energy itself. So, and that's what really our life depends on, this energy. All type of energy is really very, very crucial for us. And the fossil fuels, oil, gas, coal, they provide the bulk of this energy. Also, you have the nuclear power and the hydro power. They really can be, and the wind power, they can be used as source of energy themselves. Now here, the definition here, you can see these definitions here. What is work? Is the application of force over distance, correct? And we measure work in joules. Energy is the ability to do work. That's what I say. I don't see the energy, but I feel its work on my foot. The rock hits my foot. Then I feel the pain. That's the work. That's the energy done on my foot. But I can't see. I cannot see an energy per se, but I feel its impact or its work on me. Power is the rate of energy flow. So power, when I say power, that's the rate of the energy per time. So like watts is 1 joule, correct, per second. Okay, so those just for you, just the definition. And the energy can be measured in many ways, correct? So we have kinetic, we have potential. At the end is we really put this 1 joule per mole. Per mole material you are combusting or are reacting or using for initiating this energy. Work is the application of force over distance. Energy capacity to do work, that's what we said. Power, yeah, we mentioned that. So here, look at this. Joule work needed to accelerate 1 kilogram 1 meter per second. Okay, 1 ampere per second flowing through the ohm. That's for electrical type of energy. We are using the ohms. We are using the amperes. What's this joule per second? Terawatts is 1 trillion watts. And this one here, just to show you here, let me just take here, just to, we have capital M, okay, we have small k, that's small, capital small, that's capital, that's small, that's capital here, and capital G, and capital T. Well, K stands for kilo, M for mega, G for giga, correct? And T for tera. Now, K, kilo, and it's for the metric is 10 power 3. 10 power 3. So you can write kilo or just write 10 power 3. It's the same meaning. Then you have mega here. Mega here. This is 10 power 6. You have giga here, 10 power 9. And then you have tera, A here, 10 plus 12. Now, in the business, they don't like the way we are doing in science. In business, if you go on Wall Street, they don't deal with this, correct? Well, what the deal with this? Kilo is what would they call it? Kilo. In the business, if you go Wall Street, they don't use this. It may get tera. They use what? That's thousands. Okay. How about 10 power 6? What they use? Millions, correct? How about 10 power 9? They use what? Billion. How about tera? They use what? They use trillion. So those million, trillion, billion, thousands, that's not the scientific way to express those. Those are mostly finance, accounting, and business areas. They use it, this one. But we use always the kilo, the mega, the tera, the giga, and with the value of them. And we agree with the business people, with the accounting people, that we are dealing with the same power. If I have a million, which is a mega, I have 6 zeros and 1, correct? And if I have a tera, I have 12 zeros and 1, and so on. So just to give you the idea of those units here, correct? So, can I take this one out? Can I take this one out? Take it out? Okay. So, you don't have to memorize it, but at least you get the idea whenever you find a finance person or a business person, you know how to deal with those numbers. So, fossil fuels, those are carbon-based, and those, as you see, that's dead bodies, mostly it's dead bodies through millions of years compressed by high pressure, high temperature, correct? Those are fossils. Those fossils, if you take them and extract out of them the thick liquid coming out, that's most of the time is crude oil. So from dead bodies, we get what most of the time, crude oil. And gases, mostly natural gases. So some of those rocks that hosting those fossil fuels, they have both. They have crude oils and gases, and mostly natural gas, correct? And that's happened not in 1 year. This takes thousands and millions of years, so it's not happened one time. But as I said, if you eat anything anytime, you remember that you have eaten a dead body, correct? Don't be offended, but that's really happened. Whenever you eat anything, think about this fruit is coming from a soil that's had its nutrition from somehow millions of years or thousands of years of a dead body there in that area, correct? So a dead dog, a dead fox, a dead whatever, a dead human, whatever that might be. But that's a dead stuff. My wife does not like to hear that, but anyway, so she does not like at all to say that because I disturb her eating, her lunch eating. So, but that's the fact. That's we have to know. That we end up back ash to ash. We are back to the whole thing, and our minerals is being used back again as a cycle. We're being used by this. But the plant is dead, then it's whatever its minerals it does have, it will go back to the cycle. Everybody dead, it goes back to the cycle. So coal resources are greater than we can use. Well, as you see, the brown coal is all over the world. However, the usage of it is accompanied with a lot of global warming because it produces a lot of carbon dioxide. So coal is always a source of burning coals is is accompanied with a lot of CO2 gas, carbon dioxide, which affect the global warming. We use coal because it's cheap, and we have, plenty amount of it available all over the world. Correct? All over the world, there you can find coal. And this is just the total resources is estimated to be 10 trillion metric ton. And that's several thousand years supply. Thousands and thousands will stay with us. But coal mining is dirty, dangerous activity, and it has to do with a lot of heavy metals such as lead, mercury, produce side effect, and you have a lot of carbon dioxide is produced when you use this coal as a source of energy. Coal burning releases huge amount of air pollution, as I mentioned this one here, and one of the major one is CO2 gas, which causes the global warming. Why is it global warming? Somebody will did I mention that what global warming is? We said CO2, correct? Mm-hmm. Why then CO2? Well, it has to do with the density. The carbon dioxide density is higher, much, much higher than the density of air. So when CO2 goes up in the atmosphere, it will remain there because its density is heavier. The air go through, and the air will be above, correct? Now this CO2 acts like a small, tiny cloud, preventing the heat to go through. Whatever heat we are producing is not released to outside, outermost space. It's not. It's stayed there, and it will be reflected back to us. And that's what's meant by global warming. The heat we are producing is not vented into the space, outer space, correct? Rather, it's kept inside because of the CO2. Now, the sun radiation is so strong, it penetrates CO2 clouds. It go in, but then when it will go out, then you'll see it will not go out 100%. Some of it will be kept by the CO2 cloud, heavier density. So, coal contains toxic, besides CO2 issue, coal also contains, as I said, a lot of toxic impurities such as lead, mercury, arsenic, chromium. All those are released into the air. That's what I said. And it is possible to make either gas or liquid fuel out of coal, but this is expensive. You can heat the coal with liquid and then get whatever out of it, but that's very expensive. So rather they heat the coal directly. When you heat the coal directly, then you are dealing with a lot of air pollution due to CO2, and air pollution through the whole heavy metals will be dumped as oxide inside the air. Lead, mercury, chromium, arsenic, all those elements will affect the air. Coal usage is declining in the U.S. That's as you can see, 2012 EPA mercury and air toxic standards are proposed. A limitation on carbon emission are making coal plants more expensive to operate. So in order to decrease the amount, let's have heavy fines and heavy fines on those plants, or heavy money if somebody wants to make a new plant. Would cost that person a lot of money to just a normal like nuclear. So nuclear power is cheaper than those coming from the coal, because the coal is very dirty plants, as you can see if you go to their manufacturing areas. And some Europe, I think it's the same thing like us. They are out of it. Their usage is very minimum. But still, China, India, the big source of pollution of our air and our planet. India, Brazil, China, those big countries, they're still using a lot of coal, which is really not healthy. Domestic oil supplies are limited. Well, that's always true. And the oil will stop maybe in, they said, about 100 years plus. You will see crude oil will be running out. So the U.S. has used more than half of its technically recoverable petroleum resources. This amount will decrease per time. I think all the crude oil in the whole planet will disappear in 100 plus years, so maybe 150 or maximum 200 from now. There will be no crude oil because it's already consumed and nothing left out of it. Extreme oil and tar sands extend our supplies. Tar sands are composed of sand and shale particles coated with bitumen, a viscous mixture of long-chain hydrocarbons. Now, those hydrocarbons, by far, much more friendlier than the coal itself. The amount of the heavy metals such as lead, mercury, chromium, they have least. So they are much more healthier for our usage than the usage of coal itself. Shallow tar sands are excavated and mixed with the hot tabor and stream to extract the bitumen. So the tar sands much better than the coal itself, since coal will provide you with a lot of other elements which is then dumped into the air, which is very toxic to our health. The U.S. also has large supplies of unconventional oil. Oil shales are fine-grained sedimentary rock rich in a solid organic material called kerogen. Like tar sand, kerogen can be heated, liquefied, and pumped out like crude oil. Well, here it is. They have rocks, and those rocks, they have inside them oil, gas. So how in the world they will get into them? So you have to fracture them. You have to break them in small pieces. So you release the oil, the gas, and you release the oil out of them. They call it cracking, or they call it fracturing. All this the same name. Natural gas is growing in importance. What is natural gas? Somebody will tell me. Natural gas. What's natural gas? Natural gas. We heard about natural gas. We use it for heating. Well, natural gas is. I'll stop here. Natural gas is this is natural gas, CH4, methane. Now, what we get inside that's a real one, that's natural gas. But we get sometimes a mixture of propane, methane, butane, hexane, a mixture of light gases. But the major one is methane is a natural gas. I'll stop here. I will see you this Wednesday, and I hope by then I have couple of those quizzes corrected. Thank you very much.